In this video, we are going to summarize what we have done in derivative. By definition, the derivative of f of x is limit of f of x plus h minus f of x over h as h approaches 0. The geometric interpretation of derivative is derivative of a function at a point is the slope of the tangent line at that point. And the physical meaning of the derivative is the instantaneous rate of change of the function at that point. One more time, the instantaneous rate of a function refers to the rate of change of the function at a specific point. It corresponds to the slope of the tangent line at that point. Let's find the derivative of f of x equals x3 plus 3x2. By definition, f prime of x is limit of f of x plus h minus f of x over h as h approaches 0, which is the same as limit of x plus h to the power of 3 times x plus h to the power of 2, f of x plus h, minus f of x minus x3 minus 3x2 over h as h approaches 0. We know x plus h to the power of 2 is x2 plus 2hx plus h2, and x plus h to the power of 3 is x3 plus 3x2h plus 3xh2 plus h3. Therefore, we can expand x plus h to the power of 3 and 3x plus h to the power of 2. Then collect the like terms, factor h, reduce it, replace h by 0, we get f prime of x equals 3x2 plus 6x. Similarly, we can find the derivative of f of x equals 7 divided by x plus 3, which is limit of f of x plus h minus f of x divided by h as h approaches 0. Instead of divided by h, we say times by 1 over h, common denominator, reduce it by h, replacing h by 0, we get the derivative equals to negative 7 over x plus 3 to the power of 2. Next example, derivative of f of x equals square root of x2 plus x is f of x plus h minus f of x over h as h approaches 0. To find this limit, we multiply both the numerator and the denominator by the conjugate of the numerator and replace x plus h to the power of 2 by x2 plus 2hx plus h2. Reduce it by h, replacing h by 0, and we find f prime of x equals 2x plus 1 divided by 2 square root of x2 plus x. The derivative of a function does not exist at the point of discontinuity. If the function is discontinuous at x equals a, the derivative of f of x does not exist at x equals a. Whenever you have a sharp turn, it's called cusp. The slope of the tangent line when x approaches, let's call the point C from the right side and left side, are not the same. We say the derivative does not exist at cusp point. If the tangent line is vertical at a point, the derivative does not exist. For example, f of x equals x when x is greater or equal than -1, and if x is smaller than -1, minus 2x is discontinuous at x equals -1. Right side limit and left side limit are not equal. The right side limit of f of x at x equals -1 is -1, and the left side is 2. Since function is discontinuous at x equals -1, the derivative of the function at x equals -1 does not exist. F of x equals absolute value of x plus 1 plus absolute value of x minus 2 is not differentiable at x equals -1 and at x equals 2. At -1 or 2, the graph looks like a sharp turn, and the derivative does not exist at those 2 points. F of x equals cube root of x2 minus 1. At x equals 1 or x equals -1, the tangent line to the graph of the function is vertical. Therefore, the derivative at those points does not exist. To recap, we say the derivative is limit of f of x plus h minus f of x as h approaches 0. Derivative does not exist at a point of discontinuity of function f of x, at cusp point, and where the tangents are vertical. Thank you.